Okay, so question number 4. Draw the Lewis structure of a carbonate ion, which is CO3 2-, and include the resonance structures. Okay, so when writing out the Lewis structure, we first need to find out the total number of valence electrons in the carbonate ion. So carbon has 4 valence electrons, and oxygen has 6. And since we have 3 oxygen atoms, we multiply this by 3. And also notice that the overall charge of our carbonate ion is -2, so we need to add an additional 2 electrons to our total electron count. So now if we add up all our values, we have 18 plus 2 plus 4, which is 24 valence electrons. Okay, so now let's try to draw a skeletal structure where we have carbon bonded to 3 oxygens. So notice that our carbon doesn't have a full octet yet, so one of our oxygens will be double bonded. So now let's draw in all of our electrons and count how many electrons are in the structure. So each bond contains 2 bonding electrons. So we have 8, and in the form of the lone pairs, we have our 24 valence electrons in total. Okay, so this structure is correct, but we also need to take into account where our negative charges will be. So to do that, we need to calculate the formal charge. Okay, so the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons. So these are the electrons that are lone pairs, minus the number of bonding electrons divided by 2. Okay, so let's calculate the formal charge of carbon. Carbon has 4 valence electrons, and since there are no lone pairs on carbon, there are 0 non-bonding electrons. And there are 4 bonds to carbon, so we have 8 bonding electrons divided by 2 to give us a formal charge of 0. So now let's calculate the formal charge of a single bonded oxygen atom. So oxygen has a formal charge of 6, or valence electrons equal to 6. And on a single bonded oxygen, there are 6 non-bonding electrons. And a single bond, so we have 2 bonding electrons divided by 2, which gives us our formal charge of -1 for both of the oxygen atoms. So we can show this on our molecule. And let's just also calculate the formal charge of our double bonded oxygen. Again, there are 6 valence electrons, but the number of non-bonding electrons is now 4. And since we have a double bond, we have 4 bonding electrons divided by 2, which is a neutral atom. Okay, so this is one of the resonance structures of the carbonate ion, and we can draw 2 more where we just show the double bond on a different oxygen every time. So for example, we can show the double bond on our middle oxygen, and we also show how the negative charges would realistically kind of rotate between all of the oxygen atoms. So that's one resonance structure. And here is the last one. And just showing all of the lone pairs and all the charges. Okay, so these are the three resonance structures for the carbonate ion. So now let's see what the junior tutor said. The Lewis dot structure represents the arrangement of electrons, shown as dots, between atoms in a molecule. The atom must follow the octet rule or the tendency of atoms to prefer to have 8 electrons in the valence shell. Individual formal charge of each atom as well as the overall formal charge must be satisfied. Okay, so they started off drawing the skeletal structure of a carbonate ion, with carbon in the center since carbon is less electronegative than oxygen. Step 2, they calculated the total number of valence electrons, so they also got 24. And they showed the single bonds between carbon and oxygen, and noted that the central carbon atom doesn't follow the octet rule, so one of the lone pairs on oxygen must be shared with carbon, forming a double bond. Okay, so they have the correct Lewis structure, they just didn't put the charges. So this solution is correct. Note that each single bonded oxygen will have a formal charge of -1. Write in -1. But this solution is correct.